On question 1, we're given f of x is equal to 15x cubed plus 19x squared minus 4. And in part A, we are asked to find f of -1. So we're going to sub in -1 for x, and we're going to get 15 multiplied by -1 cubed plus 19 -1 squared, take away 4. And -1 cubed is -1, so this is going to be -15. -1 squared is +1, so this is going to be plus 19. And then we're going to take 4, and that equals 0. Now, it doesn't ask us what the significance of that is, but we have found that when we sub in -1, we get 0. And so from the factor theorem, we know now that x plus 1 is a factor of f of x, and that's going to be important. In part 2, we're asked to show that 5x minus 2 is a factor of f of x. So we can say that if 5x take 2 is a factor of f of x, then if I sub in 2 0, that's 2 over 5. So if I sub in 2 over 5 into f, I should get 0, because there'll be no remainder. Okay, so that's factor theorem again. So let's sub in 2 over 5 and hope we get 0, and if we do, then it's a factor. Okay, so we're going to get 15, this is 2 over 5 cubed, plus 19, 2 over 5 squared, take away 4, so this is 15, 2 cubed is 8, and 5 cubed is 125, plus 19, and then we've got 4 over 25 here, and then take 4. And we can say that equals 0. And because it equals 0, we can say, therefore, 5x minus 2 is a factor of f of x. Okay, and then for part B, we're asked to simplify fx squared minus 6x over f of x. And so to do that, we're going to write f of x as a product of its linear factors so we can see what cancels. So we've got the first factor is x plus 1, we found from parts AI, and then another factor is 5x minus 2. Because it's cubic, there's going to be another factor here, ax plus b, and we're going to find out what they are. And we know it should all equal 15x cubed plus 19x squared take 4. Okay, so just by equating the coefficients, if I do 1 multiplied by -2 multiplied by b, so -2b, that's going to give me the number term when I expand all of this, and the number term should equal -4, so that gives me that b is equal to 2. And when I multiply the x terms, x, 5x and ax, that's going to give me the x cubed term, and that's got to equal 15. So I get 5a has got to equal 15, so a equals 3. And now I've got f of x in terms of its linear factors. So now I know that f of x is equal to x plus 1, 5x take 2, and now 3x plus b. Okay, and because I've got it written like that, I can go back to this fraction that I'm trying to simplify, which was 15x squared take away 6x, and it was over f of x, but I'm going to write f of x as x plus 1, 5x take away 2, and then the final factor we just got 3x plus 2. Okay, and I'm going to factorise the top, the numerator, so I'm looking at it and I can take a factor of 3x out. So let's do that, which means that inside the brackets I'm going to get 5x minus 2 and underneath I've got x plus 1, 5x minus 2 and 3x plus 2. And you can see straight away that this and this are going to cancel, and I just get 3x over x plus 1 over 3x plus 2. Okay, and it's fully factorised, so that's it, that's the solution. Cool. So question 2, we're asked to write cos x plus 3 sin x in this form, r cos x minus alpha. Now, if I look in the formula book that I have, you can see that r cos x minus alpha can be written as r multiplied by cos x cos alpha plus sin x sin alpha. Okay, so we know that alpha is a constant and we know that r is a constant, so this is a constant and this is a constant and also this is a constant. So what I'm going to do is I'm just going to equate what I have in white with what I have above in yellow. So I'm looking at the cos term here, cos x term, and because I've got one cos x, down here I'm going to have r cos alpha cos x, which means that firstly r cos alpha has got to be equal to 1, so that they're the same. And then look over here, look at the sin x's. I've got 3 sin x on the top, and on the bottom I'm going to have r sin alpha, lots of sin x. So I have r sin alpha has got to be equal to 3. And now I'm going to just find out the values of r and alpha, so I can sub them back into this at the top and find out what the expression is. Okay, so to find out what r is, what we do is we square both of these expressions, this one, and we add them together. Okay, so if I square this one, I'm going to get r squared cos squared alpha is equal to 1. And if I square this one, I'm going to get r squared sine squared alpha is equal to 9. And if I add them together, I get r squared sine squared alpha plus r squared cos squared alpha. And this should be squared there. This is just r squared because sine squared plus cos squared equals 1, and they've both got a factor of r. And this should equal 10. So we get that r equals the root of 10. Now to find out the value of alpha, I can sub that r value back in, but there's a way I can also do it without doing that, so I'll show you that. And that is to divide this one by this one. So I'll get r sine alpha divided by r cos alpha. Well, the r's are going to cancel, and I'll just get tan alpha. And r sine alpha was 3, and r cos alpha was 1, so this should just equal 3. So, therefore, alpha is tan to the minus 1 of 3. Okay, and we're working in radians, so let's just do that. Make sure I'm in radians. Okay, and it's going to be tan to the minus 1 of 3. And I get 1.249. So alpha is 1.249 to 3 decimal places. That's what we want. 1.249. And so now we've got the r value and we've got the alpha value. I can go back and say that cos x plus 3 sine x can be written as root 10 cosine of x minus 1.249. That's what we were trying to show. Okay, so now for part B, we want to write down the minimum value of cos x plus 3 sine x. Well, the minimum value is going to be when cos x minus 1.249 is negative 1. Because cosine can only take values between 1 and minus 1. So the minimum that this can be is minus 1. So the minimum that cos x plus 3 sine x can be is minus 1 times root 10. So the minimum is just negative root 10. So the next question, find the value of x in the interval 0 to 2 pi at which this minimum occurs. So we know that cos of theta equals minus 1. We're trying to find when it's minus 1, when theta is pi radians. Okay, that's just from the cosine curve. When theta is pi radians, we get a value of negative 1 for cos theta. So I'm just trying to find the value when theta is pi. I get negative 1. So just looking to find the value of x that makes that value pi. That means that x take away 1.249 has got to be pi to make cos of it negative 1. So x is equal to 1.249 plus pi. Which gives me, let's just do that on the calculator. That was my answer from before, so I'm going to just add pi on. And it's 4.391. Okay, so when x is 4.391, I take off 1.249 and I get pi, and cos of pi is -1, so that's when it's minimum. Okay, and then finally, part C, it's asking us to solve the equation cos x plus 3 sine x equals 2, and in the interval 0 to 2 pi, giving all the solutions to 3 decimal places. Well, we've already shown that we can write this as root 10 cosine, and it was x minus 1.249. So we're trying to find when this equals 2. So that's going to be when cos of x minus 1.249 is equal to 2 over root 10. And 2 over root 10, let's just work out what that is. 2 divided by, 2 divided by the square root of 10. It's 0.632. To 5. Okay. So we're going to try and find the solutions that make that true. So we're going to do this by substitution. Let u equal x minus 1.249. And so we're going to solve cos of u equals 0.6325. And we're going to be looking for values of u between minus 1.249, because the problem we were given was between 0 and 2 pi, and u is the x value take away 1.249. So 0 take away 1.249 is this, and then up here we're going to go up to this value here. 249. Okay, so I just do inverse cosine on my calculator to find a value of u. Inverse cosine 0.6325, and I get a value of u 0.886. So I get a u value of 0.886. I'm going to look at the cosine graph, which starts at 1 and then it comes up here. But remember, I'm looking at the negative bit of it as well. I'm going from minus 1.249 upwards. So this is pi and this is 2 pi. So 0.886 is going to be about here. So I'm also going to get a value of negative 0.886, and the next time I'll have a value that satisfies the equation will be 2 pi minus 0.886, but we're only looking for values of u between 2 pi minus 1.249, so I don't have to use this one here. I just get those two values there. So they're the values of u, and to find out the values of x, I just say that x, it was x minus 1.249 should be equal to 0.886 minus 0.886. So to find out what x is, I'm just going to add 1.249 onto both of those. So I've got 0.886 plus 1.249. I get 2.135. And 1.249 take away 0.886 gives me 0.363. So there's my two values of x. Question 3, we're asked to do the binomial expansion of 1 plus x to the minus a third, right? Now you do binomial expansions in C2, so can someone tell me what's the difference between a core 3, what's the difference between a core 4 binomial expansion and a core 2?
Yeah, like, you have the x in it. No, you have like fractional powers.
Fractional powers and negatives, yeah, and this one's both. Okay, so in your formula book, can you all look for this? Make sure you know where it is. In the formula book, Harry, just do this right. Go for your formula book, right? Okay. You want to write down the binomial formula 1 plus x. Now, when you do it in C2, you do the chooses on your calculator. You can't do the chooses the same way because they're going to be fractional negative.
Very interesting formula. There is a place called T.
Is that?
It's in Denmark.
All right. Okay, that's interesting, isn't it?
I'm not sure how it got it so light. We can do.
And then it looks like this. The formula, and it's got this factorial.
The x squared.
Yeah, and there's an x squared there. There's a factorial on the bottom. The way it's written in the formula book is that they just write 1 times 2. Okay, but essentially, let's get rid of that because that's not the next term, is it? Next term is going to be n take 2, and then it's all going to be over 3 factorial, and then that's going to be x cubed, and so on like that. So you see the number on the top is n multiplied by n minus 1 multiplied by n minus 2. The number on the top goes down by 1, and the number on the bottom goes up by 1, and you multiply them together. So sometimes you see a lot of stuff cancels. So sometimes it's not the best thing to write 3 factorial on the bottom like that. Might be just worth writing 1 times 2 times 3, so you can see what cancels. Does that make sense? Okay, so let's do it for this one then. 1 plus x to the minus a third. So what's the first term going to be? 1. And the next term?
Minus a third.
Minus a third x, yeah. And then it wants us to go to the x squared term, so I've only got to do one more. So the next term is going to be minus
that.
Yeah, well, I'm going to add on minus a third for the n. And then I'm going to, what's minus a third take away 1? It's minus 4 thirds, right? Is everyone happy with that? Okay. And then on the bottom, I'm going to have 2 factorial, which is just 2. It's 1 times 2. And then I've got x squared, and it only wants me to go up to there, so it's dot, dot, dot. Okay. So I'm just going to tidy this up. I've got 1 take away a third x. Now what do I get on the top here? The negatives are going to cancel, so it's going to be positive. I'm going to get 4 ninths over 2. So that's going to be 2 ninths. Okay, any questions with that? So for AII, we're asked to do 1 plus 3 over 4 x to the power of minus a third. Okay, and all I do is just do exactly the same thing, except I change all the x's for 3/4. So I'm going to get 1 minus a third times 3/4 x, I sub the x in as well, plus 2 ninths, and this is at 3/4 x all squared. Okay, very good. Okay, so minus a third times 3/4, that's just minus a quarter. And then here, I've got to square the 3/4, so that's going to be 9 over 16. And the 9's cancel, so it's 2 over 16. So this is just an 8th. Right, does everyone agree with that? So that's the answer to one. Can you find me the expansion of this thing? And it's the cube root of 256 divided by 4 plus 3x. Okay, so it doesn't look very nice, and it says this is equivalent to some sort of expansion. So, where do I go with this? Yeah, you're absolutely right. I could write that as 256 over 4 plus 3x all to the power of negative a third. That's true. I think there's something I'm going to do first. Well, that's true as well. You're telling me lots of things that are true, and I don't think I'm just trying to make it as clean as possible.
Forget about the 256 first.
Well, yeah, I think you're right, Aaron. It's twice today. This is the cube root of 256 multiplied by, let's keep it like this for the time being, the cube root of 1 over 4 plus 3x. Is everyone happy we can do that with surds? I've just like broken that apart. And I think what we're going to do then is do what we said we would do with Taz, what Taz said we would do. I'm going to keep the cube root of 256, I don't know why I wrote 3. 256 there. And then what's in the bracket, did you say, Taz?
4 plus 3.
Yeah. Negative because it's 1 over, yeah. And no, it's just a third. It's just the cube root. 2/3 would be the cube root and then squared. Now, why is this looking good or not? Look at what it's a hence. So look at what we've already done in the question. Yeah, this 4 plus 3x, this bracket here, 4 plus 3x to the power of minus a third, is almost the same as. In fact, it's just 4 times. Yeah, there we go.
Can you not, to make it easy, just change that 3 the cube root to 66?
I just leave that for a moment. It's a number. I can deal with that later.
And then it would be our answer to IR.
Perfect. So we want to take a 4 out, but it's not quite as easy as that. I'm going to take this. I'm going to keep the 256 there, the root 256, and I want to take a 4 out of that bracket. How do I do that?
Make it brackets times core. Cube root.
Oh, the way you because this isn't just this is a whole bracket to the power of minus a third. Okay, so if I want to take a 4 out of it, let's put a dot and multiply. I don't just take a 4 out. I take 4 to the minus a third out, and then I'm allowed to. And then inside here I would have that. Can you see that? Because it's just like what I did with the surds. Because they have the same power, it means I can move them in. So I have to take 4 to the power of minus a third out. Okay? Everyone happy with that? Okay. So this 1 plus 3 over 4x to the power of minus a third. I know what that is. I've done that. Let's just try and work out what this bit in front is. Okay? So, this is, what's 4 to the power of minus a third? What does a minus do? Makes it 1 over 4. So it's a quarter. So this is a quarter to the power of a third. So this is the cube root of 256, and to the power of the third is a cube root as well. So it's multiplied by the cube root of a quarter. And then I've got this thing. Okay. And I can put these two things together because again they've got the same root. So it's actually the cube root of 256 over 4 times that. Now, let's just say, so what is it? What's 256 over 4? 64, and then a cube root it. Cube root 64? 4. Okay. So this is just 4 lots of what I had before. Which is quite easy to do, because what I had before, let's just write it out one more time. what I had before, so it's going to be 4 lots of what I had before, and what I had before was it 1 minus a quarter x, and then it was plus an eighth x squared, I think. Let me just double check that. Yeah. So this is just 4 minus x plus 4 over 8, which is a half x squared. And so in this question, A is 4, and B is -1, and C is a half. On question 4, we're given a fraction, an algebraic fraction, and we're asked to write it in a form which involves an integer and then 2 fractions, so partial fractions. The first thing we should notice is that the numerator here and the denominator have the same order. So what I'm going to do first of all is I'm going to just do algebraic division and divide the top by the bottom. So I'm going to multiply at those brackets on the bottom, and I get 5x squared plus 4x take 1, and we're going to divide, we're going to do algebraic division, we're going to divide 10x squared, and I'm going to put in here 0x just for the placing, and then 8. I've got 0 lots of x. So I say, what do I have to multiply 5x squared by to get to 10x squared? I have to multiply it by 2. So I put 2 at the top, and then I multiply all of this by 2, and I get 10x squared plus 8x, take 2, and then I just take these away from each other. I'm going to take these away from each other, I get -8x, and that's going to be plus 10. So what we found is when I divide 10x squared plus 8 by x plus 1 multiplied by 5x minus 1, it goes in twice, but there's a remainder of this, minus 8x plus 10. This is the remainder. Which means that I can rewrite this fraction first of all like this: 10x squared plus 8 over x plus 1, x minus 1. It went in twice, and then there was a remainder, and the remainder was 10 minus 8x, and that remainder would be still be divided by x plus 1. So that's how many times it went in. Okay, so that's where my 2 comes from, and now I'm going to break up this second fraction here using partial fractions. So I'm just going to deal with this 10 minus 8x over x plus 1. Seem to be missing some x plus 1s up here. X plus 1, x plus 1 there. 5x minus 1 here. Okay. And this can be turned into partial fractions like this. Okay. So what I'm going to do is multiply both sides by the denominator on the left-hand side, and that's going to give me 10 minus 8x. Now when I multiply by x plus 1, 5x minus 1, the x plus 1s are going to cancel on the first term. So I'm going to get a lots of 5x minus 1. And then the 5x minus 1 term is going to cancel on this one, and I get b x plus 1 here when I multiply across. And now I'm just going to equate coefficients In fact, I'm going to use substitution. So let's let x equal -1. And when x equals -1, on the left-hand side I get 18. And on the right-hand side I get 5 times -1 is -5, which is -6a. And in this second bracket, because I let x equal -1, I get nothing. Should be -6a. So no b terms. So -6a equals 18. So that means that a has got to be -3. And then I'm going to let this time let x equal 1/5, and if I let x equal 1/5, then on this side I'm going to get 10 minus 8/5, and that's going to be equal to, well, when I let x equal 1/5 in this first term, that's going to go, and so I'm just going to get 1 plus 1/5, which is going to be 6/5 of b on the right hand side. Okay, so let's just have a look at this. 10 minus 8/5 is going to be the same as 50/5 minus 8/5. This still equals this. Okay, so multiply everything by 5, and this gets me 42 is equal to 6b, and so b is 42 divided by 6, which is 7, I think. So I've got b is 7, and a is -3, and I've already done the algebraic division, so I can go straight ahead and write down that 10x squared plus 8 is equal to x plus 1, 5x minus 1, divided by that, is equal to 2, because we found that it went in 2 times, plus we found out a was 3, -3, over x plus 1, and we found out b was 7, that was over 5x minus 1. Okay, so that's done. And then it says, hence find the integration, hence integrate this. Well, the integration of this does not look very nice, but if I write it in the way we just did, which is equivalent, it's just the integration of this, which looks a little bit nicer. It's because I can integrate each term separately. Okay, so if I integrate 2, I'm going to get 2x. If I integrate minus 3x plus 1, then I'm going to get minus 3 ln of x plus 1. And if I try and integrate this last term, then I'm going to get, it's going to be ln of 5x minus 1. There's definitely going to be a 7 in front of it, but if I were to differentiate this and try and get it back to the same, I'll multiply by 5, so I'm going to have to divide by 5, so this is going to be 7/5. And there's a plus c on the end. So on question 5, you're given x squared plus xy equals e to the y, and it wants you to find the gradient of the curve at point -1, 0. So to find the gradient, we need dy dx. So we're just going to differentiate all of this with respect to x. So this is implicit differentiation. So I do x squared differentiated with respect to x. So if I differentiate x squared, I get 2x. And then this next term, xy, is a product of two functions. So I have to use the product rule. So it's going to be the differentiation of x times y. Well, that's just going to be 1 times y, so that's just y. And then it's going to be the differentiation of y times x. So that's just plus x dy dx. And then I do implicit differentiation on this e to the y. And when I differentiate e to the y, I get e to the y. But then I have to multiply it by dy dx. And that's it, it's been differentiated. I want to find dy dx when x equals -1 and y equals 0. So I'm going to sub those in. So when x equals -1, I'm going to get -2 plus 0 minus dy dx is equal to e to the 0, which is just 1 times dy dx. And bring the dy dx over, I'm going to get -2 is equal to 2 dy dx. And so dy dx equals -1. So on question 6a, we're asked to express sine 2 theta and cos 2 theta in terms of sine and cosine. Well, you just use your formula, but it's this compound angle formula. So sine 2 theta, I can write that as 2 lots of sine theta, cosine theta. And cos 2 theta, again using the compound angle formulas I've got, I can write that as cos squared theta minus sine squared theta. Okay, so that's part A done. It then asks me to show what sine 2 theta is, given that cos theta equals 3/5. Okay. Well, I don't need to find out what theta is to do this. Cos theta equals 3/5, so that means that cos squared theta is equal to 9/25. Okay. And sine squared theta is equal to 1 minus cos squared theta, which is going to be 1 minus 9/25, which is going to be 25 minus 9/25, which gives me 16/25. And so sine theta is the square root of that, which is 4/5. Now, this means that sine 2 theta at this point, so I'm talking about when cos theta equals 3/5, that sine theta is 4/5, so this becomes 2 times 4/5 times cos theta, which is 3/5, which is going to give me 24/25, which is what I wanted it to be. And this one gives me cos squared, which is 9/25. Take away sine squared, which is 16/25, which gives me -7/25. Okay, so I found the value of sine 2 theta and cos 2 theta at when theta takes the value that cos theta gives you 3/5. Okay, so for part B, we're given that x equals 3 sine 2 theta, and we're given that y equals 4 cos 2 theta, and we're asked to find dy dx. So to do that, I'm going to do dx d theta, to differentiate with respect to theta, and this is going to give me 6 cosine 2 theta, and I'm going to do dy d theta, which is going to give me -8 sine 2 theta, And dy dx, what we're after, it's going to be dy d theta divided by dx d theta. And dy d theta is minus 8 sine 2 theta, and this one's 6 cos 2 theta, so this is going to be minus 8 over 6, which is minus 4 over 3 sine 2 theta over cos 2 theta. So there's the equation for the gradient dy dx in terms of theta. Okay, and then for part BII, it's asking us to find the equation of the tangent when cos theta equals 3/5, which is what we had before. So to do that, I use the line equation. I need a y value that the line goes through. I need the gradient, and I need an x value that the line goes through. Okay, so let's just work those out. y1 I can find because it tells me y equals 4 cos 2 theta. Well, I know what cos 2 theta is because I worked it out earlier. Cos 2 theta was minus 7 over 25. So this is minus 7 over 25 here. And an x value that it goes through, well, x equals 3 sine 2 theta, and sine 2 theta was 24 over 25. And the gradient is just dy dx at that value. So this is minus 4 over 3, and a sub sine 2 theta in, which is 24 over 25. And I divide by cos 2 theta, which was minus 7 over 25. And the 25s are going to cancel, and the negatives are going to cancel, so I'll get 4/3 24 over just 7. Okay, and the 3 is going to cancel with the 24, so this is going to be 4 times 8, which is 32 over 7. Okay, so I'll just sub all of those things into this equation, and that will be the equation of the tangent. So it's going to be y minus y1, and y1 is going to be 4 times negative 7, so that's minus 28, so this is plus 28 over 5, over 25, is equal to the gradient. Well, we just worked out the gradient is 32 over 7. X, take away the x value that the line goes through, 3 times 24 is 72, so it's 72 over 25, and that's the equation of the tangent line. Question 7, we've got to solve this differential equation. There's only one method you have, which is separation of variables. So you want to get the y onto the left hand side and the x is onto the right hand side. So this means bring the y over there, so I get there, and then the cos is just in terms of x's, and then I'm going to integrate both sides.
You've got to take the dx across.
Yeah, so this is going to be the integration of y with respect to dy should equal the integration of cos x over 3 with respect to the dx. Is everyone happy with that? Right, what do I get on the left hand side?
Y squared over 2.
Y squared over 2. There's going to be a plus. There's going to be a plus c, but there's also going to be a plus a constant on the right hand side. So I'll lump them together in a minute. Integration of the right hand side. Cos would have come from sine, so it's going to be sine of this. Now, when I differentiate that, when I differentiate sine x over 3, I get cos with a third in front because I've had to multiply by the differentiation of x over 3. So if I differentiate that, I get 1/3 cos x over 3, so I need to put a 3 in front of it. Okay, plus some constant. So I've lumped the constants from both sides. Everyone happy with that? Okay, and let's just write it as y squared because that's what it wants. So y squared is equal to 6 sine x over 3 and it's going to be 2C, but I don't know what C is, so I'm just going to change it to a new C, C dash or C1 or something like that. But I didn't know what C was, so times it by 2 doesn't make any difference. Is everyone happy with that? That there is called the general solution. We're now going to find a particular solution because we know that when y is 1, x was what? Pi over 2, so this is going to be pi over 6 plus c. Pi over 6 is it a half or minus a half?
Half.
It's a half.
Yeah.
So sine of pi over 6 is a half, so this is going to be 6 times a half, which is 3, plus c. So c equals -2. Okay, so the actual particular solution, what it's asking you to find, y squared is equal to 6 sine pi over 6 plus, plus the c I just found, which was actually -2. Okay, in question 8 we're given 3 coordinates A, B and C. I'm going to write those straight away as position vectors. O to A I'm going to write as 2, -1, -5. O to B is 0, 5 and -9. And then O to C is 9, 2 and 3. Okay. It also tells me that there's a line, and the line has the equation, or the position of points on the line have this position vector 2, -1, -5. That gets you onto the line. Then you move along the line by a scalar in this direction. So lambda's just a scalar. Okay, so first of all we've got to verify that point B lies on the line. Okay, well if point B is on the line, then a position on the line is given by the line equation, and this should be equal to any position on the line, and if B is on the line it should be equal to the position vector of B. Okay, and the way we can check whether this is true is if lambda has the same value for the x component, the y component and the z component. So let's have a look. Just looking at the x's, I get that 2 plus lambda equals 0, and that gives me the lambda equals -2. And looking at the y's, I've got -1, -3 lambda equals 5, and if I sub in -2 for lambda, that satisfies that as well, so -2 for that. And finally I've got -5 plus 2 lambda equals -9, and if I sub in -2 for that, I get -9, so that's satisfied. So I have to check that all the lambdas are the same for each thing. Okay, so therefore point B is on L. Okay, so for part B, we want to find the vector B to C. Well, B to C is O to C, take away O to B. And I've got both of those things. O to C is 9, 2 and 3. And I'm going to take away O to B, which was 0, 5, -9. I'll take those away from each other, and I'm going to get 9, -3, and plus 12. Okay, and that's the vector B to C. Now, part C, we're told that A to D is equal to 2 lots of B to C. I've just found out what B to C is. It's 9 -3, 12, so 2 lots of that is going to be 18, -6 and 24. Okay, now we want to show that D has particular coordinates. So how do I find what D is? Well, I can write down that O to D is the same as going from O to A and then going from A to D. And I know what O to A is. I don't know what A to D is, but I do know that it's equal to 2BC. And I know what 2BC is because I just worked it out. It's that. So now I just do O to A as well, which is 2 minus 1 minus 5. And then I add on 18 minus 6 and 24. And that gives me 20. Take 7 and 19, and that's the position vector of D, and so D has the coordinates 20, minus 7, 19. Okay, and then finally for part CII, we want to show that P to D, where P is a point on the line, is perpendicular to L. And if that's true, then P to D, dotted with the direction of L, which is just that bit of the line, that should be 0. The dot product should be 0 if they're perpendicular. So what I need is a way to write down P to D. So I can do a similar trick to what I've just done. Yeah. P to D is O to D, take away O to P, and O to D is something we just worked out. Somewhere.
Damn, there's some plastic in there.
O to D is 20 minus 7, 19. Oh, jeez. And I'm going to take away O to P. Well, O to P is a point on the line, so I just put the line equation in for this. For a particular lambda P, and so I just put all this together, so I've got 20, take away 2 is 18, minus P on the top line. I've got minus 7 plus 1, which is going to be minus 6. That's 3P minus 6. And then I've got 19, take away minus 5, so that's 24, take away 2P. And so that's P to D. Okay, so what I want to do is dot P to D, which is this. And I want to dot it with the directional component from the line, and that should be 0. So let's just dot it, so it's going to be 1 times 18 minus P, and then it's going to be minus 3 times 3P minus 6, and then it's going to be plus 2 lots of 24 minus 2P, and all of this should equal 0. So I'll just add all this up. I've got 18. Plus 18, so that's going to be 36, plus 2 times 24, so it's 48, plus 36, which gives me 84. And then put the p's together, I've got minus P, minus 9P, so that's minus 10P, minus 14P. That should all equal 0, so 14P equals 84, and so P has got to be 7. Okay, on question 9, we've got growth of a certain species of toadstool. We're told that when the height is 57 millimeters when 12 hours have elapsed. And the scientist thinks that this is the model used for the height of the toadstools at a certain time. Okay, so part A says find the height of the toadstool at when t equals 0. Okay, when t equals 0, we get h equals a, 1 minus e to the 0, because t is 0. E to the 0 is 1, so we get 1 minus 1, so this is just 0. Okay, so the height is 0 at time 0, which is what you'd expect. Okay, and then in part 2, it asks us to find out what a is. Well, we can do this because it's told us in the question some information. It's told us that it has a height of 57. So I'm just putting 57 is equal to a 1 minus e to the minus a quarter, and it says it's got a height of 57 when t equals 12. Okay, so let's just sort all this out. I need that there. So this gives me 57 is equal to a 1 minus e to the negative 3. Okay, and so a has got to be 57 over 1 minus e to the negative 3. And if you put this in your calculator, you're going to get 57 divided by 1 minus e to the negative 3. You get 59.9865, but to two significant figures, that's 60. Okay, so that's AII. Okay, so now it wants us to take the same model, but this time we know what the A is. It's 60, so I put it in like that, and it wants me to rearrange for t when the height is 48. So let's put the height in as 48. Okay, so it tells us the height is 48, and we want to find out the time, so we sub 48 in, and I'm just going to rearrange, so I divide by 60, so this is 48 over 60, which goes to 12 over 15, which is 4 over 5, and this is equal to 1 minus e to the minus a quarter t. I'm going to take away 1 from both sides, so this is 4/5 take 1, which is going to be minus a fifth. That equals that. I'm going to times by minus 1 on both sides, and ln. So I get ln of a fifth is equal to minus 1/4 t. Okay, and again I can times both sides by -1. So I get this, and the negative can come inside the ln and make that just 5 equals a quarter t, and so t equals 4 ln 5. Okay, and so A is 4 and B is 5. Okay, for part II, we want to start differentiating this, so I'll write down the equation again, what we're trying to differentiate. Minus a quarter t. I'm just going to multiply this out so I can differentiate a little bit more easily, so this is minus 60 t. So if I go through and I do dh dt, the differentiation of 60 goes to 0, and I'm going to get differentiation of minus 60 e to the minus a quarter. The minus a quarter is going to come down and give me 15 e to the minus a quarter t. Okay, this isn't quite how they want it, so I'm going to go back up to the expression for h, and I'm going to divide it by 4 because I'm looking at this h divided by 4. So h divided by 4 is equal to 15 minus 15 e to the minus a quarter t, and h over 4 minus 15, it's going to be minus 15 e to the negative a quarter t, and times by minus 1, I'm going to get 15 minus h over 4 is equal to 15 e to the minus a quarter t, which was what we had when we did dh dt. So that means that dh dt is 15 minus h over 4. It's the same thing as that. And then very finally, part 3, it says find the height of the toadstool when the rate of growth is 13 millimeters per hour. Well, that's the growth rate. That means that that's the gradient is 13. So just sub it into here. So I get 13 is equal to 15 minus h over 4, and we're trying to find the height. So 13 take away 15 is going to be negative 2, and that's equal to minus h over 4. So h is going to be 8 millimeters. And that's it.